In this video, we're going to go through some practice problems to look at solving triangles and determining when to use which law. In part A, it says solve for side length x. We're given an angle and two sides, and we have a missing side. We need to use the cosine law to find the missing side because the cosine law relates three side lengths and a given angle. Our angle of 24 degrees is contained between side lengths 3.6 and 4.8, both in meters, and the opposite side to the given angle is x. When we set up the cosine law will be expressed in terms of x squared on the left-hand side is equal to 3.6 squared plus 4.8 squared minus 2 times 3.6 times 4.8 times the cos of 24 degrees. You can evaluate the entire right-hand side of the equation all in one step on your calculator. And to solve for x, we take the square root of that result. Make sure you leave that value in your calculator and don't do any early rounding. And we're going to round our answer to two significant figures along with the same units as found in the original question. Question B is very similar to question A. We're given two side lengths as well as an angle and asked to find the missing side length. One thing to make note of is that in this question, we're working with mixed units. We have 6 feet and 3 inches as well as 5 feet and 5 inches. In Math 145, we looked at an entire unit on measurement conversion. Before we begin this question, we're going to convert the two given side lengths to the whole number of inches. Recall that 1 foot is equivalent to 12 inches, therefore 5 feet and 5 inches is equal to 65 inches, and 6 feet and 3 inches is equal to 75 inches. Now we're going to take those values and solve for j as we did in part A. Pause the video and try it on your own. After setting up an equation for j squared, we solve for j and find that it is approximately equal to 6 feet and 11 inches. In part C, we're asked to find a missing angle. In this question, we're given three side lengths. To find angle B, we apply the cosine law. Notice we can't use the law of sines because we'd have to have a pair of side lengths and angles. And since we're only looking for an angle, not given one angle, we cannot use the law of sines. Our angle B is contained between side length 7 feet long as well as 6 feet long, and the side length across from angle B is 8 feet. Using our rearranged equation to solve for cos of angle B is equal to 6 squared plus 7 squared minus the side across from it, 8 squared, divided by 2 times 6 times 7. Remember, when we evaluate this on our calculator, you must put brackets around the top of the fraction as well as the bottom of the fraction. When we reduce the right-hand side of this equation, it is equal to 0.25. But we haven't solved for b yet. We've just found cos of b. To express b as an angle in degrees, you need to make sure that your calculator is degrees, and we get cos of inverse is 0.25, which is equal to 75.5 degrees. In part D, we're given three side lengths and finding the missing angle. Again, the angle we're looking for is angle G, and it is contained between the side length of 52.75 and 83.5. Before we proceed any further, it's important that you check that all of your side lengths are measured in the same angle, same units, and they are. And the opposite side to our angle is 47.25 inches. Now pause the video and set up an equation to find angle G using the cosine law as we did in part C, and compare your work to what is posted here. And when we solve for G, round it to 1 decimal place, we end up finding that it is equal to 31.4 degrees. In part E, we're asked to find the missing angle D, and we're given 2 side lengths as well as another angle, 27 degrees. To solve for D, we use the law of sines. We know this because we have 2 pairs of angles and side lengths, as shown here. When we set up the law of sines, when we're solving for an angle, it's best to put the sign of the angles on top of the fractions. We get sine of angle D divided by 67 is equal to sine of 27 degrees divided by 32. Now we can solve for sine of angle D being equal to 67 times sine of 27 degrees divided by 32. And when we evaluate this all in one step on our calculators, we get 0.9505 ... And the last step is to find for angle D by finding the sine inverse of that ratio. Make sure you leave that number saved in your calculator so you can reuse it again. And we find that angle D is equal to 71.9 degrees. Question F is a challenge problem. It says a triangular traffic island has sides 21.5 feet, 46.2 feet, and 37.1 feet. What are the angles at the corners? The first thing we should do is draw a diagram. We can label our 3 side lengths. It's also helpful to label the angles within the triangle. So we have angle A, angle B, and angle C. You can label those angles to be whatever you like. Just make sure that when you are calculating a particular angle, you refer to the variable from your diagram. To find our first missing angle, we're going to apply the cosine law because we already know 3 side lengths and we want to find a missing angle. It's worth mentioning that there are many ways that you could go about solving this triangle. At this point, using the cosine law, we could find angle A, B, or C, and then the rest of our solution would go from there. I'm going to arbitrarily choose to find angle A. So when setting up the cosine law, angle A is contained between side lengths 21.5 and 37.1, and the side length across from angle A is 46.2. Using the cosine law, we can solve for angle A. Here we find that cos of A is equal to negative 0.1854. Now we want to consider the positive ratio and solve for the reference angle in the first quadrant, like we did at the start of the set of notes when we were solving trig equations. We find that alpha is equal to 79.3 degrees. Now using the CAST rule, we want to figure out where cosine is expected to be negative. We know that cos is negative in the second quadrant and the third quadrant. In calculating the value of each of these angles, we see that we get 100.7, and within quadrant 3, it's not possible to have an angle in quadrant 3 when we're looking at the angle of a triangle. A must be an angle less than 180 degrees because it's one of the angles of a triangle. Now we only have one possible value for angle A, and it's 100.7 degrees. Using our solution for A, we can find another angle in the triangle. At this point, we could choose to solve for B or C. We have enough information to find either one, but we can use the matchings of the side lengths and angles to apply the sine law. Continuing by alphabet, let's find angle B. So applying the sine law, placing the angles on top, we get sine B divided by the side length across from it is equal to sine of the angle that we already have, 100.7, which is angle A, divided by the side length across from angle A. Now we find that sine of b is equal to 0.7891, and therefore b is equal to 52.1 degrees. It's actually worth mentioning that to find angle b, we could have applied the cosine law again, but setting it up relative to angle b being our contained angle. So there's so many different ways to solve these problems. Just make sure you proceed slowly and check for small errors as you go. To find our last angle, angle C, I'm going to use the Sum Angle Theorem, and that tells us that every triangle has 180 degrees in it. So we can subtract the two angles that we have just calculated, and we find that angle C is equal to 27.2 degrees. Therefore, the angles at the corners are 100.7 degrees, 52.1 degrees, and 27.2 degrees. I encourage you to explore this question over again and try finding a different order of angles. So you could start off by finding angle C, and you could try applying the cosine law for all three of the angles, and you will find the same answer no matter which approach you take. Okay, best of luck, and make sure you contact your professor if you have any questions. At this point, we've covered modules 1, 2, and 3, and all three of these modules will be covered on the first test coming up soon.